Hi, all of you, welcome to this YouTube channel. In this video, we're going to discuss about contact analysis experiment of the beam. Here the beam is as shown in the figure at having the length of 100 mm and width 10 mm and thickness 10 mm. The middle of the beam is steel having the Young's modulus of 200 gigapascal are rigidly constrained at the outer ends. A 10 kilonewton load is applied on the center of the upper portion of the beam and caused to bend and contact the lower portion of the beam. In main menu, select preference, select structural, click OK. Next is preprocessor, element type, add element, add, select solid, select quad 8 node 183, click OK. Select option, enter the element behavior as plane stress with thickness, click OK. Close this. Next step is to set a real constant, add, again add, click OK. Enter the thickness value as 10 mm and click OK. Close this. Minimize the real constant. Next step is metal properties, metal model, structural, linear, elastic, isotropic. Enter the Young's modulus of the steel, that is 2 e power of 5 and Poisson's ratio 0.3 and click OK. Close this. Minimize the metal properties. Next is to create a model. Create areas, rectangle, bidimension. Enter the x1 value as 0, x2 value is 100, y1 value 0, y2 value 10 and click apply. Now to create a second rectangular, for that x1 distance 50, x2 distance 150, y1 distance minus 5, y2 distance minus 15 and click OK. So here the modeling part is completed. Next step is meshing, size control, manual size, lines, all lines. Enter the element edge length as 1, click OK and go to mesh, areas, free, select the two rectangular areas, click OK to complete the mesh part. Minimize the meshing. After completing the mesh part, next to assign the contact, go to the contact manager, select contact wizard, select the line, select the pick target. So here it is the target line, click OK, then click next, select the lines, ensure the contact element type should be surface to surface, select contact, select this line, then click OK, click next, uncheck the include initial penetration, then create and then finish. Then close this contact manager visual. After creating the contact manager, next step is to apply the boundary conditions. Next step is solution, analyze type, new analysis, static analysis OK, minimize, define load, apply structural, displacement, on lines, select this line and select this line, click OK. Select all degrees of freedom, enter the displacement value as 0, then click OK. Next step is to apply the force or moment. Select node, select the node at the top of the beam, upper beam, at the center, click OK. Change the direction of the force into Fy, enter the force value as minus 10,000 Newton, click OK. To minimize this, minimize, and next is solve current LS, click OK. So you get warning message or verification, click S to execute the solution. So here the solution is done. Close this. Next step is to get a result part. General post browser, plot result, deform shape, select deform plus undeform, click OK. So here the displacement values happen. So the displacement is 6.32631 mm for the given boundary condition. Plot result, nodal solution, deform solution, displacement vector, click OK. So here it is the displacement vector for the given boundary condition. To save this file, plot control, write meta file, select inverted white or black, enter the file name as displacement plot. Next is nodal solution, stress, select 1 stress, click OK to get a stress plot. So here the maximum stress is acting at this region. The value of the stress is 3712.78 Newton per mm square. To save this file, plot control, write meta file, select inverted white or black, enter the file name as stress plot. Next, nodal solution, go to contact, select contact pressure and click OK to get a contact pressure between the two beams. Here the maximum contact is at this junction. The value is 3,87,382 Newton per mm square for the given boundary condition. I hope this video will be very useful how to solve a contact analysis problem. Kindly support this channel, like, share, comment, subscribe this channel to get a further update. Thank you all.